Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without much wasting time, we will be quickly moving on to our topic. We have been discussing about the various units and the used in the measurement system. We have already discussed what is measurement, what is meant by unit, and what are physical quantities and its types. So today in the last class we have concluded with the various units that are being used to measure the length. Today we will be discussing about the units which are used in measuring physical quantity like mass and time. Okay, fine. So let us first see what are the units used for measuring mass. Okay, so for measuring mass, what are the units that are used for measuring mass? So the most common unit, as you know, is actually kg. Okay, it is also the SI unit. You know the SI unit of length is meter, but the SI unit of mass is not gram, but rather it is kilogram or kg. Okay, so how we have already discussed that how we have defined the unit meter, that is 1 meter. So likewise, there has been also a definition given for 1 kg or 1 kilogram, isn't it? So what is the definition for 1 kilogram or 1 kg? So first of all, write the heading units of mass. Okay, so we will be discussing about the various units of mass. Fine. So the most common unit used for measuring mass is the kg or kilogram. Rather, it is also the SI unit. So kilogram is the SI unit of mass. So how it is defined? How it is defined kilogram? So see, as we have defined initially the meter as the distance of the length between 2 points marked on a platinum iridium rod, which is kept in the International Bureau of Weights and Measures in France. Okay, like that, the mass 1 kg has been defined as the mass of a cylindrical piece of platinum iridium alloy. Okay, so kilogram has been defined as it is the mass is equal to the mass of a cylindrical structure made of platinum iridium alloy, okay, which has been kept in the International Bureau of Weights and Measures in France. Okay, so the structure has been fixed, and the mass of that particular structure is taken as to be 1 kilogram or 1 kg. Okay, so again, so if we had only one unit, that is 1 kilogram, rather it would be quite inconvenient to express all the masses in terms of kilogram. Say we have a very small mass, so you must all of you have went to the jewelry shop or sometimes seen the masses of the jewelries that your mother or your sister generally wears. Okay, so those jewelries are very small, isn't it? They are having a very less mass. Now if you want to express the mass of a jewelry in kilogram, it is rather very inconvenient. The mass of a jewelry, so the earpieces that are worn on the ear, those jewelries may be having a mass of something, say 5 zeros, okay, or say 6 zeros, or say 7 zeros. That kind of expression you have to use. So if I want to express the unit of mass of a say very small earring, okay, so small earring, that mass can be as small as say 2 into 10 to the power minus 7 kilogram. Okay, it can be as small as this, okay. So it is very inconvenient to express like this way, isn't it? So for measuring the mass of various substances which are having very less mass, we use the smaller units of masses like gram, milligram, centigram, okay. And if we want to you measure the mass of very heavier objects, like you want to measure the mass of a sack containing rice, a huge amount of rice, rice, okay. So for that, what you need to do, you need to actually use bigger units of mass. Say we will be generally using tons, okay, or quintal, like those kinds of units are used for measuring the masses of larger units, okay, fine. Now, so I think the concept of mass is clear to all of you now, okay, and the units are used, okay. So now let us quickly move on to the next physical quantity, that is time, okay. So what are the units of time, okay. So the most common, not mostly common, but the SI unit of time is second, okay. So SI unit of time is second, fine. So the SI unit of time is second, okay. This is the SI unit. Now how can you define second, okay. So second initially had been defined in terms of the solar day, okay. You know what is a solar day? The time interval in between the sunrise and sunset, okay. So sunrise, one sunrise of one day and the sunrise of the next day, that is the one solar day, okay. So the time interval second has been defined in terms of the solar day, but afterwards the definition of the unit second was rather changed to a more useful form or more convenient form, and it has been defined as the time interval of a very big number is there, 91, 92, 61, 770 vibrations of a radiation corresponding to the transition between two hyperfine levels of the ground state of cesium-133 atom. So that the definition is very difficult and it is quite difficult for you to understand this level. So rather you can also define, you can just memorize it a little bit, okay. Actually it is related to radioactivity. So what we are saying that we are taking cesium atom, which is radioactive in nature, and when the cesium atom emits radiations, okay, between two certain radiations the interval is taken as 1 second, okay. So the latest definition has been given in that, in terms of that, okay. Now the bigger units of time that we use are say minute, hour, okay, like this. These are the bigger units, and often we also use the units like day, okay, then year or decade, millennium. So these are the bigger units, and the smaller units can be as small as microsecond, millisecond. These are the smaller units that we use to specify the time of various intervals, okay, fine. Now here see, actually, so at the end of the discussion we can actually conclude that every physical quantity, the units that are being used in every physical, measuring every physical quantity, have some multiple units as well as sub multiple units. In order to measure the larger quantities we use the multiple units, and in order to measure the smaller quantities we actually use the sub multiple units, okay. So in every kind of unit system there are multiple and sub multiple units, okay, corresponding to the SI unit, fine. So this is we are coming to the end of this chapter, okay. But before ending the chapter we will be just briefly discussing about the rules that we follow while writing a unit, okay. What are the rules regarding writing a unit? So there are certain rules regarding the writing a unit, okay. So what are those rules? Let us discuss. So guidelines for writing units. So we write guidelines for writing unit, okay. So what are the guidelines used for writing unit? Okay, let us see one by one. So the first thing that we need to keep in mind is that when you are writing the full name of a unit, it has to be always written in small case letters. Okay, the unit may be named after a scientist or may not be named after a scientist. That is not the problem. It has to be always written in small case letters when you are writing in full form, full form. So let's say the meter, it is to be written in small letters, small cap letters. Okay, you all know the SI unit of force, that is Newton. It is named after the scientist Sir Isaac Newton, but still when it is written in full, it is written in small case letters. Okay, small case letters. Now, when you are coming to the second point, when you are writing the symbol of a particular unit, say meter, if it is the unit meter is not named after any scientist, so when you are writing the symbol of such units which are not named after a scientist or any well-known personality, we use small case letters to write the symbol M for meter. But while you are writing the symbol for the SI unit Newton, which is after the scientist Sir Isaac Newton, it is written in uppercase letter, capital N. Okay, so in this way, while writing the short form, remember whether it is the unit is after any scientist or any famous personality, so you have to write it in capital or uppercase letters, and if it is in not named after any such personality, then the short form is written in small case letters. Okay. Okay. So these are the two facts that you have to remember while writing the unit. Okay. Again, there is another third point that you should remember, that while writing the unit of the derived quantities. Okay, derived quantities. Say you are wanting to write the SI unit of speed or say density. So the SI unit of speed must be written like this: meter per second. It is written as meter dot s to the power minus 1. It is incorrect to write it as m/s. This is actually the incorrect notation. Okay, please do not write it like this, write it like this. Similar is if you are writing the SI unit of density, so it is say like kg per meter cube. So kg dot into the minus 3. It is incorrect to write it like this, kg/meter cube. We often write it like this, but actually you should avoid it while writing like this. You should actually follow this technique. Okay, so these are some of the points that you must remember while writing the SI units. Okay, so with that we conclude with the first part of the chapter. In the next part we will be discussing about some of the instruments that are being used for measuring various physical quantities. Specifically, we will be talking about vernier calipers. Okay, then there is screw gauge. Okay, so we will be discussing such three instruments. Okay, so we will be discussing that in the next class. Okay, till then please do study well. If you have any query, any doubt, please do mention it in the comment section so that we can solve your queries. We will be happy to help you. Okay, so please until the next video, do study well. Have a good day. Thank you.